Okay, thank you and welcome everybody. A few words about me before we start. My name is Gianluca Sartori. I'm an independent SQL Server consultant, a data platform MVP, and I've been working with SQL Server for a very long time, which means I'm old. And currently, I'm working as a DBA at a famous Formula One team in Italy. And if you want to read my blog, you can find it at spaghettidba.com. My handle on Twitter is at spaghettidba. So, what's the topic for today? It's benchmarking. So, first of all, we will see the scenarios. So, why we do this and what we are after by taking benchmarks. And then we will see what are the challenges involved in benchmarking. And then we will see that if we move to the cloud, things get even more complicated and we face even more challenges. But hopefully the solution is Workload Tools, which is what we will introduce at the end of the session. And we will try to use it to take some benchmarks. Okay, so so let's go. First of all, what's a benchmark? It is something that describes performance of your system in a given scenario. So if I went to my server, took a picture of what performance looks like, that's a benchmark. And that's useful for assessing the current state of my system, but it becomes even more interesting if I want to compare it with other benchmarks. So imagine that if I changed something in my server and I wanted to compare that to my current situation, that would be very interesting. Imagine changing something in the hardware. So maybe you change your storage or your hardware, your machines, or you change something in the software like upgrading SQL Server or any other part of your software stack. Or maybe you virtualize a physical server, or you migrate your servers to a different data center, and you want to understand whether that has a positive or a negative impact on performance. You have benchmarks for that. And other things you may want to do with benchmarks, you maybe want to change something at the server level, like activating some trace flags or changing configuration options, or something in the database, like adding, removing indexes or changing code in your stored procedures and views, and you want to know whether that is good or bad in terms of performance on the overall workload. You have, again, benchmarks for comparing that and for finding out. So what's inside the benchmark? As we said, we have some performance data that describes the state of the system globally. So things like performance counters, like batches per second or CPU. But we could also have things like wait stats that describe what the system is waiting on. But the most important part of the benchmark is the workload itself. So the source queries that determined the performance numbers that we are observing on the server. And along with the queries, we also want to capture some performance figures, especially related to queries in particular. So for each query, we would also have things like the duration, the CPU, the reads, and the writes in order to understand what's the shape of the workload. So the overall process looks like this. We have our production server, hopefully, and we have something, a tool that is pointed at the production server and captures all the queries and saves them inside the benchmark along with the performance data. So then we have the test environment, the one that we want to compare with the production environment. And we have a tool that reads all the queries inside the benchmark and replays them against the test environment. And while the test is being hit by the replay, we also have the same tool that again captures the queries, saves them to a benchmark along with the performance data. So now we can compare the two. And things we want to catch at this stage are regressions. So imagine that you are migrating from an older version of SQL Server to a newer one. You want to know whether you had some regressions in the process. Queries that used to run very well in the source environment that don't run so well in the target environment. And things that stop working altogether, or other things you may want to extract from the comparison is how good your tuning efforts are. So if you ever try to do this, you probably know that this is a bit complicated, not impossible, but really complicated. And it all has to do with the choice of the tool for capturing, replaying, and comparing, analyzing the results. And we had a number of tools for this in the past, like RML utilities or distributed replay profiler and ClearTrace and many others. And working with them always looks like this. You have your production database and you want to capture some data from it using some trace or XCL files. So trace or extended events. So you have to run this capture for a meaningful amount of time. And once the capture is over, you take a tool to process all the files that you have captured. And then we have some analysis data that goes into an analysis database. Then we also have a stub file, a set of stubs files actually, and we can use these in order to run the replay. So again, we have a tool that takes the stub files and uses them to run the replay against the test database. And again, we need to capture while the replay is running, capture to trace or XCL files. And then at the end of the replay, we can take these files, analyze them, and write to the analysis database in order to run reports on top and compare the start workload with the target workload. It looks pretty straightforward, but actually it is not. And many things can go wrong in the process, especially if you have to capture a long workload and write it to a set of files, the disk could fill. And you don't want to fill the disk on a production server because the database would probably stop working. And it's not a good idea. And also, processing a set of huge trace files can easily crash the tools that we had in our hands, like read trace from RML utilities or the distributed replay can easily crash if they run against a set of big files. And the same can happen even at the later stage when you analyze the files coming from the test database. So this is again something that take into account. And Also, if you're moving to the cloud, things get even more complicated because many of these tools rely on features that we don't have in the cloud. So if we are moving to infrastructure as a service, obviously this is just a VM on someone else's hardware. So we can use all the tools that we want. But if we move to platform as a service, we have two choices: managed instances or SQL database, and they both come with some limitations. Especially they cannot run traces because they don't have access to the local storage. So the only option is using extended events, but again, you cannot write directly to the file system. You have to write to blob storage, or you can use event streaming, but only on managed instances. It doesn't work on Azure SQL database. And obviously, performance monitor is not supported. So all the performance counters that you can have are those available through DMVs on SQL Server. So this is why I created Workload Tools. Workload Tools is a collection of open source command line tools for working with benchmarks. So it takes care of all the aspects of benchmarking. So capturing, analyzing, and replaying a workload. And also Workload Tools comes with two unique features. It works against Azure SQL database and managed instances, and also can do real-time captures and replays, which is something that you cannot do with the traditional benchmarking tools. So we have two main concepts behind Workload Tools: the listener and the consumer. The listener is what takes care of capturing the events from a source, which could be extended events or SQL trace, depending on the version you are working with, or even a file where you saved a workload previously. So any of these three can be used as the source from which you are reading from your execution events. And then from the listener, you can have multiple consumers that take care of processing the events that come from the listener. So you could have a consumer that is capable of writing the workload to a file, so you can use it later as a source for analysis or replay. And then we have consumers for analyzing the workload. So this will be capable of writing analysis data to an analysis database. And then replay consumer, which is capable of taking the events from the listener and replaying them against a target instance of SQL Server. It is super easy to configure, so all you have to do is use a JSON file where you fill some information for the listener and the consumers. And then once you're done, you can analyze the data in the analysis database using either the built-in workload viewer, which is a GUI application in the tool set, or using Power BI. There's a dashboard included with Workload Tools that helps you visualize the data in the analysis database. How does it look like to work with Workload Tools? Let's see some typical scenarios. The first one is how you analyze a workload. So you have your production database, where the application is writing data, reading data. And what you do is you use SQL Workload, which is one of the tools in the tool set, to run the capture. And this happens by streaming the events directly from the production database. You don't have to write the events to a file, which is very, very convenient. So you will not fill the disk on your production server. You stream the events directly from the database. And then you can analyze these events on the fly. You don't have to wait till the end of the capture in order to analyze the data. You can analyze it on the fly as the events flow to a SQL workload. And also the queries that you capture get normalized. So this means that all the literals that you have inside your queries get stripped away and replaced by placeholders so that you can analyze together all those queries that differ only by the values hard-coded inside the queries. And then all this data gets summarized every 1 or more minutes, depending on how you configure it, and written to intervals inside an analysis database that contains all the performance figures related to the specific normalized queries. And then you can run reports on top to see what's the shape of the workload. So let's try to do this. I have a virtual machine here where I have some database running. And what I want to show you is how to analyze a workload using Workload Tools. So first of all, we will start a synthetic workloads that will run against this DS3 database. It simulates the activity of DVD store, which is something that shows its age. It would be something about Netflix probably today. But still it works. It runs some queries against this DS3 database. So we said that we want to analyze the workload, so we can do it by using Workload Tools, and we will run this analyze.cmd that runs SQL workload.exe and uses as the input a JSON file that contains all the configuration. Let's have a look at the JSON file. It contains the definition for listener and consumers. So the listener is an extended events workload listener. It could also be a SQL trace workload listener or a file workload listener, depending on what you are willing to do. And all we have to do is specify the server name to attach to, in case even the database name. And if we have some filters, we can specify them here. So we can filter by application, database, or host name, or login name. In this case, I'm only filtering by database name. And here we have the list of the consumers. So in this case, I want to analyze this workload. And all I have to do is use an analysis consumer and specify where to write the database, the data that comes from the analysis. So it will be written to SQL 2019, database SQL workload 1, schema name capture, and will create intervals of 60 seconds. So let's try to run that and analyze. So it runs SQL workload and it says, okay, I'm connected and I'm waiting for events. This will capture all the events and write them to an analysis database every 60 seconds. Let's have a look at what the database looks like. So what we have here is a SQL workload 1 database, and inside we have some capture schema with some tables inside that contain the analysis data. And if we leave this running for a while, for, well, at least 1 minute, we should see that it aggregates some data and writes it to the analysis database. And obviously we would have to leave this running for a meaningful amount of time in order to have something to show you. So instead of waiting for 1 hour or more, I will show you some data that I have captured previously. All I wanted to show you is that we captured these events. It's 4,000 and more rows. So this means all these events were captured. By normalizing these events, we only got down to 22 distinct queries. So the data is aggregated by those 22 queries. So I can safely stop this because we don't have 1 hour time to wait for this to finish, but I can show you how it looks like if we leave it running for some time. This is the workload viewer, and we'll show you the performance numbers coming from the analysis database. So here at the top, you can filter by application, database, host name, and login name. In this case, we only have one. But here we have three charts to display CPU, duration, and number of batches per second. So you can see over time how this has performed. You can even zoom into a particular point in time. And what is interesting is the second tab. We have the queries. So here we have all the queries captured in the workload, ranked by total duration, average duration, CPU time, total and average, and reads and execution count. So if we rank this by total duration or average duration or CPU or whatever makes sense for you, you have the queries that consume more resources. So the ones that you probably want to start tuning from. And that's also available broken down by application, database, host, and login, and you can see it performing over time. So that's pretty cool, I think. And what else can we do with Workload Tools? We can also save a workload to a file so that we can use it later for running replays or doing other stuff. So again, we have a production database. We will use SQL workload for capturing the workload. Again, we are streaming the events, so no need to write to the storage of the production server. What we will do is save to a file that could be sitting anywhere. So on the machine that is running SQL workload, which could be the DBA's laptop. It doesn't need to be the storage of the production database. So what can we do once we have this file available? We can use it again as a source to stream the events, pass them again to a SQL workload so we can analyze them and write to the analysis database and run reports. We could do this at a later time. We don't have to do it in real time as we did in the previous example. So let's see how this can be done. And we will go back here. We will capture this time workload to a file. So we will run SQL workload again. We will use again a JSON file. Let's see what it has inside this time. So again, we have a listener and consumers. The listener is the same as before. So an extended events workload listener that listens on SQL 2016 and filters on only this database. And then we have two consumers this time, just to show you that we can combine more than one. The first consumer writes the analysis data directly to the analysis database, but the second consumer takes care of writing the workload to a file. And as you can see, this is a SQLite file. So it's a database. It's a SQLite database, which is really convenient for manipulating the data or filtering or doing anything we want with this data, even before we set it back to SQL workload. So if we want to run this, we can run this capture. We still have the syntactic workload running. It's here on the background. And as you can see, we have this data that is getting written to this SQL workload.SQLite file. And it should be saying, okay, I wrote 1,000 events, and it goes on like this. Every now and then says, okay, this is how many events I have written to the file. So not much to see here. What I want to show you is what we have inside the file. So let's have a look. I will open it with this DB browser for SQLite. So it's actually a database client, and you can also browse the data inside. What do we have? We have this events table that contains all the queries captured by SQL workload. So you can use them to replay the workload against the target environment. So let's close this and see what it looks like when we do a replay. So again, we have the production database. We have SQL workload that takes care of receiving the events from the stream. Otherwise, we could also use a file as a source for the event. We have seen how to capture one, so we could also use it as a source for the replay. And SQL workload can send events to the analysis database using an analysis consumer, but can also send the events to a replay consumer that takes care of replaying the events against a test database. And if we have a second instance of SQL workload running that receives the events from the test database, we can send the analysis data to the analysis database, and we can run reports on top. And this can also happen in real time. So you can point SQL workload to the production database, and in real time, we will have the replay happening against the test database. And with the second instance of SQL workload running, we can have analysis data flowing from both databases in real time and see the comparison of the two workloads in real time, which is, I think, pretty cool. So let's try to do that. I have my environment here. I still have the synthetic workload that is running against my first environment. So what I want to do is run the real-time replay. So this time we need two instances of SQL workload, because one will run against the source, one will run against the target. So we'll have a replay CMD that uses a replay JSON, and replay JSON has one listener of type extended events, so receives the events from the source directly, and uses a replay consumer to connect to an Azure SQL database, why not? And we'll also use an analysis consumer to write the analysis data to an analysis database. Then we need a second instance of SQL workload to analyze. So this will use an analyze JSON. Just have a look. And we have an extended events workload listener here that connects to the target, which in this case, it's an Azure SQL database. And we'll also need to have a target path that will contain the URL to the blob storage where we have the extended events data. And the consumer this time will receive the events for the analysis, so write to SQL 2019. We don't have the time to run this. Also, would need to run for a meaningful amount of time. So what I can show you here is that we have both things running. So this is a replay that it's starting one worker for each SPID, and we'll need to connect to the target and run all the commands. But obviously this takes a huge amount of time. So what I will show you is what we obtain once we have it running for a long time. So this is the data that comes from one of my customers who wanted to migrate from SQL 2008 to 2017, and they were not really sure about performance. So we had this running for a while against production and replaying all the events to the target environment, so 2017 in real time. And here you see that green is the source, so the baseline, and black is the benchmark. So we could go here and see that in general, it was not bad. Performance was quite the same, better at some points and worse at others. And we could also go here to the queries, and now we have more columns, so we can do the difference between duration in environment 1 and environment 2. So here, this is a regression, and we can start tuning from these queries that are those that need some tuning to avoid regressions. And we also can see this broken down by application, database, host, and login, and see how these behave over time. We would need much more time than we have to show you this and completely, but just I hope this was enough to give you a rough idea. So benchmarking used to be hard, but with Workload Tools now it's super easy. I will also leave you some resources, some links in order to go and have a look at the documentation on GitHub. And I have some blog posts on my blog that describe how to use the tool. And this is a blog post that describes how to set up blob storage to capture extended events on top. And this is all I had for today. And thank you for attending. If you have some questions, I'm here to answer all your questions. Or if you want to shoot me an email, just go ahead and do it.